This is a section of an artery showing endothelial lining and internal elastic lamina and underlying smooth muscle cells. The bloodstream maintains erythrocytes, leukocytes, platelets, and lipoproteins contact with arterial wall. This is the basic structure of LDL and HDL particles. As the ratio of LDL and HDL particles increases, there will be a high risk of atherosclerosis. The LDL particles may bind to the LDL receptors on the surface of the endothelial cells. The receptor LDL complexes is then internalized by endocytosis. Plasma LDL concentrations may exceed the regulated endocytic capacity of the cells. LDL crosses the endothelial barrier and is then trapped in the subendothelial space. The trapped subendothelial cells where they are susceptible for the oxidative stress. The oxygen free radicals including superoxide anion are released from the endothelial cells and macrophages. Monocyte recruitment plays an important role in the development of atherosclerosis. Preferential recruitment is observed at the site of disturbed flow such as bifurcation. Endothelial cells express various adhesion molecules including VCAM1 and P-selectin. Monocyte attachment to the vessel wall is initiated by P-selectin on endothelial cell, binding to PSGL1 on the monocyte. This initiates rolling, which acts to prolong the contact of monocyte with arterial wall. Monocyte adhesion arrest results when alpha-1 beta-1 integrin and the VCAM1 receptor on the monocyte is activated by rest of chemokines. MCP1 binds to its receptor CCL2 and signals for monocyte transmigration through the endothelium into the vessel wall. Monocyte differentiates into macrophages under the influence of macrophage CSF. Oxidized LDL is then taken up unregulated fashion by macrophage scavenger receptor, which leads to intracellular accumulation of cholesterol and forms foam cell formation. Macrophages are also involved in T cell activation. Activated T cells in turn secretes TNF alpha and INF gamma, which amplifies the inflammatory response. Macrophages, foam cells, and endothelial cells continue to release cytokines activating monocytes and T lymphocytes. Endothelial cells express adhesion molecules such as VCAM1 and P-selectin as well as tissue factor and CD40 ligand. CRP is produced by liver in response to that of IL-6. IL-6 plays an important role in the inflammation and activation of adhesion molecules. Thus, the inflammatory process is established. Fibroblast growth factor FGF and platelet-derived growth factor PDGF are secreted by the endothelium and foam cells respectively. These growth factors attract smooth muscle cells from the media and stimulate cellular migration and proliferation. With increased accumulation of lipids, macrophages-derived foam cells release free cholesterol into the intima. The cytokine secreted by the macrophages continues to stimulate proliferation of smooth muscle cells. Smooth muscle cells synthesize collagen, leading to the formation of fibrous cap. Smooth muscle cells may also accumulate lipids and become smooth muscle cell derived foam cell. The lipid core is soft due to the accumulation of free cholesterol from the necrotic foam cells. Active infiltration of oxidized LDL, monocytes and T lymphocytes into the intima takes place at the edges, shoulders of the plaque, where the fibrous cap is not well developed. Small feeding blood vessels grow into the plaque.